Yeah, so good evening everyone. The main thing I wanted to start with this evening is something that I think all students should be doing before they go into their exams. I think that as teachers sometimes we forget to just check that everything in the background is actually working fine. And one of the most common mistakes, such as having calculators set in radians rather than degrees, can often cause students to lose out on very, very important marks within their exams. So hopefully you can see on your screen at the moment a document that will be available to you later after this webinar. And also on the side here I've just got my calculator. When I get into the exam questions I'll make that a little bit larger. But I just want to very briefly touch on the things that we should be making sure students have got right within their calculator before they start. The first thing is to make sure they've got the latest operating system, either 3.9 or 4.0. It can be quickly checked if you go into settings on your calculator and then into status, number 4. And inside there, the students will be able to see the version. They'll also be able to see their battery, which does come up on each screen, but they probably should be looking at least 75% charge before they go into the exams, just to make sure everything's running smoothly and that there are no issues. The next thing is just to quickly touch upon is the idea of floats and making sure that there are other settings that they know how to work between each thing. Particularly for the 3CD students, the 3AB students, and even the specialist students, making sure that they know how to work between radians, exact, auto, etc. So I'm just going to go into a screen that I've already set up, and this is probably worth talking about with students as well. Sometimes they end up back on the home screen and they panic that they've lost everything. Number 4 gets them back to their current document. So number 4, and they'll have that up on their screen or whatever they've currently been working with. Now you notice I've already typed in the little equation that you're going to get on, or little rule that you're going to get on the sheet that you'll be able to access. If I press enter, you'll notice at the moment I've got this in float 6, and this document will actually take you through for your students what you have to go through to get to that. If you go into menu, into document, and within the document you can go into document settings, number 2, and all the different floats, approximations, etc. Just make sure that your students feel comfortable that they know where to find the various things. For 2CD, 3AB students, probably a good idea, float 6. Just allows the number to change to suit their needs. And also looking at the idea of things like finance, etc. So at the moment you'll notice here I've got float 6. If we make default, that will stay the case for the whole document. So that way from now on, if you turn it off, it will still be appearing. So I'm just going to go OK there. So you'll notice there that I've got my float 6. Now you may find that on the run the students need to be able to change. One of the quickest ways of doing that, particularly for finance, if they just move up onto the answer that they just got and press enter, you notice that they'll get more details in terms of their answer. So that may allow them to actually work out things like dollars and cents, for instance. Okay, just moving along on my document here. That was done within calculation mode, so our calculator. We also can do a few things in graphs and geometry, which I won't go into tonight because we have a lot of other important things to go through. But again, students can make changes within a graphs and geometry page. And again, using the same kind of process, and that's all explained here. And I guess one of the new ones for people over here, we don't tend to use R squared a lot. We tend to use the correlation coefficient R. But one of the things that will be happening towards the new national curriculum is using R squared a little bit more. So I'll just quickly touch on that and explain the settings within our document. So if I go into 1.2, I've already set up a spreadsheet here which has some data in it. I've also set up a graph, and again, hopefully people are okay with all that. I've put in a regression line, and at the moment you'll notice that we have the rule for the regression line. The thing that we're talking about here is the R squared, and just to explain the options, if I go into menu and setting, you'll notice that at the moment this is saying display digits, and at the moment it says auto. If you have auto, it will actually use whatever your normal document settings are. So again, if I go into here, you notice we have got the float options as well, but auto will just use whatever your current document settings are. The new one, diagnostics, if I click on that, and then just go OK. I don't want to make it a permanent fixture of my document at this stage. You'll notice that suddenly we have the R squared come up, so again gives the students a little bit more opportunity to see what's going on. And I guess the last thing I just want to highlight here is strongly recommend students should be using a new document when they're creating this kind of work so that they can save it. A couple of the things that Jodie and myself will be looking at tonight will involve us using notes. So if the students are actually able to save that and get it from their Access document area, they'll be actually able to use it within their exams. Scratchpad probably hasn't got the flexibility that's that useful for the students, particularly from a notes point of view. Okay, now for tonight, so this document will be available for you after the webinar, and I might just close that now because we don't need it anymore. Okay, the other thing that you're going to get access to is, from both Jodie and myself, is a series of questions. Now, for tonight, I've got 3 questions I'll try to get through if time allows. The first one, and I've tried to choose questions, I know Jodie and myself have tried to choose questions that are fairly generic, but obviously when we're dealing with an audience from 2CD, 3AB and 3CD, some of these skills might not necessarily equate to all 3 courses. But in this case, we've tried to pick things that may not specifically relate to your course, but you might be able to see some skills that can be used within the area you're teaching. So the first question I've got here is a proof and conjecture question. These 3 questions I've chosen are very, very stock standard type exam questions, not directly from the exam, but you might expect to see them fairly regularly, or at least this kind of format. So Peter makes the conjecture that the function f of x is equal to x squared take 5x plus 7 only generates prime numbers between 3 and 9 for our domain, and it can only be integers. Is the conjecture that Peter is making true? If it is not true, state the value or values of x for which the conjecture is false. So just going to close that document for a moment and come back to our calculator. So now what we need to be thinking about is how could we actually do that without the students having to formally type in the values and work out each one. And there's 7 values in total, so it wouldn't take a lot of time. But as we know, students can run short of time. It can be a bit of an issue. So a couple of ways we can do this. I'm going to create a new document, or a new problem, sorry. So I'm going to go into Doc, Insert, and number 1 for problem. And this way, what I'm doing is avoiding any duplication of the variables I've used in the previous documents. If I had have added just a new page, then I would find that those variables I used earlier would still be available within my new page, which could cause some problems. So I'm starting a new problem here. I'm actually going to, first of all, look at a calculator way of doing this. So I want to define my rule. Now, my rule was the one that we were given in the question. So f of x, control, and then our little maths template gives us our define. So it's telling us that we're going to define it as some kind of function, x squared, take 5x plus 7. I generally tell my students, if in doubt, they should put a times in between the 5 and the x. For this case, it wouldn't matter too much, but it's always a little safe thing to do. If we press enter, we've got done. So now the calculator will remember that f of x is given by that function. All right, the first way I want to look at this question is using just the normal calculator page. So we're actually going to generate a sequence. So I'm going to type in SEQ, and you'll notice it changes from italics to normal writing. Therefore, we know that we've got the right function. Now, the syntax for this is bracket. Now, f of x, now I could get this from my variable button, but I'll use that a little bit later for a few other things. F of x, the variable is x. The domain was from 3 to 9, and we want to go integers, so we want to go whole numbers, so by one. If I press return, I've now got my generated sequence. And straight away the students can actually see there which numbers they are. I guess the other important thing here is that they know what a prime number is and what a composite number is. Straight away they should recognise that 21 is obviously the number that's causing a problem with Peter's conjecture, and so they could give that list and then just talk about which number doesn't meet the requirements. Being probably a 2 or 3 mark question at the very most means that just a quick list and an answer will be more than sufficient. Obviously, once it gets to 3 or more marks, then students are expected to show a little bit more working out. Okay, another way that they could do this is I'm going to now insert a page, so Control and I, and we could do this from a list and spreadsheets point of view, so number 4. Now I'm actually going to call my first column up in the title cell, I'm going to call it A, just to avoid issues with what we had earlier with X's. I just want to make sure that we're not using the same variables. So I'm going to go A there, and I'm going to call this one B. All right, now one thing I find students don't like doing is having to type a big list of numbers. Again, we only have 7 numbers within our domain, but we could actually generate that as a sequence. So to do that, Menu, Data, and number 1. Now we're used to using TN, but the syntax here is UN. U, the previous term, so UN take 1, and then we just want to generate the numbers 3, 4, 5, 6, 7, all the way up to 9. So that's the first cell. Our initial value is 3. We want to start with the first number within our series, and we want to actually generate 7 numbers. The rest of this we can actually leave. And if we go OK, we'll now find that there's our domain, 3, 4, 5, 6, 7, 8, 9. You can change things around, particularly go steps of 2 if you're dealing with a question where it was every even number. But again, this meets the needs for our question here. Okay, the other thing we want to do is generate the sequence itself, so for the conjecture. So in this cell here, I'm going into the formula cell, which is where I also put the sequence before. This time I'm actually going to press equals, and you'll notice straight away it's saying we're going to define this whole column B, so not the reference B, but the actual variable B. Now our rule was x squared take 5x plus 7. So just to avoid the calculator having issues of knowing which is a cell and, which is a variable and which is a column reference, we can go into var, and you'll notice that A is one of our options. If I push A, you'll notice there's a little apostrophe, a little dash at the top. Straight away, the calculator now knows that we're actually talking about a variable and not the column reference. We're then going to square that, plus, 5, times, again, I'm going to use the var key, A, and actually, sorry, it was actually minus, so I'll just go back and do that. And then plus 7, and then if I press enter, excuse me, if I press enter, I've now generated the same list of numbers that we had before. And again, the students can then go through and check whether the conjecture is true. Again, for number 7, we actually end up with a number 21, which is obviously not prime. So that was question 1 of the ones I wanted to look at. Question 2. And by the way, just in terms of finishing off that question, probably I should just mention, if I was encouraging my students to do this problem, I'd be first of all saying, giving the list of numbers that they've just generated, quickly saying that the conjecture is not true. A lot of students just tend to assume the examiners and people who are marking have no clue, just can guess that they're thinking that. So make sure you stress to the students that they do answer the question and say the conjecture is not true. And then give the example that isn't working, which is obviously the number 21 for when x was 7. Okay, moving on. The next question is, and again, a stock standard probably could be used in 3AB, even 2CD to a lesser extent, and even up to 3CD, which is a function question. Now, in terms of the function question I've got here, we have f of x equals x squared plus 3 as our function. The first thing we need to do is graph the function. Then we've got a transformation. So the question says the function is transformed to produce g of x equals negative f of x plus 1. Sketch the new function g of x on the same set of axes. Describe the transformation, and then it moves on to, excuse me, state the equation of g of x in turning point form, state the coordinates of the turning point, and then state the domain and range of the function. So I'm going to start a new problem again, just to avoid the issues I mentioned earlier. So document, insert, and problem. And we're going to start with a calculator page, even though this is actually dealing with a lot of graphing. And you'll see why I'm doing that in a moment. So because we've now started a new problem, there is no problems with me using f of x again, even though I've used it earlier. I'm going to define that, so control and then our template. And in this case it was x squared plus 3. And if I press enter, we'll get done. So it has stored it and we know it's stored it successfully. Okay, I'm going to now define g of x as being the transformation. Now the beauty of using the technology is we don't have to physically go and do a proper substitution and work it out and then graph it. I'm actually going to write the transformation in exactly how it appeared on the exam. So negative f x plus 1. And if I press enter now, again, it has done. So the students can now see what the fact that it's actually remembered as a function g of x. If the students want to see what that's calculated out to be, they can just type g of x, noticing it's now in bold. So we now know that it actually does recognise that as a function. If I press enter, there's our substitution, not particularly in a great useful sense, but I'll show you how to fix that in a moment. But we now have at least what the g of x function should be. Okay, I now want to actually graph both of those functions. So control and I, and if I go into graphs, now the first one I want to do is see the original function. That was the first part of this question, was graph the original. So f of x, notice again I'm not having to type x squared plus 3. The calculator's remembering the function from the previous calculator page. If I press enter, there's our function. So straight away we can see what the graph should be and the students can draw it onto the axes that were provided. The next thing that the students were asked to do was graph g of x. Now this is a little trick. It can be a very, very useful trick for various questions. If I go control and menu, which is sort of like a right click, one of our options is text. Now I'm just going to move that text box. Actually I probably should have kept away from that in the first place, so I'm just going to do that again. So control and menu and text just into an open area. If I type y equals g of x, now at the moment nothing special has happened, so I've just typed that into the text box. But if I now grab it and move it onto either of the axes, it can be the x or y, as soon as I hit the axis, whoops, now something has just gone amiss there.
Please stop bold.
Yeah, we'll just go back to 3.1 and just see why it has lost that. So I'll just come back. There we are. Sorry, for some reason it just lost it temporarily. So once I moved that function back onto the axes, we actually end up with the graph. So again, I didn't have to type in the whole rule. The text, using the text box, straight away, once it's on the axis, it'll actually draw the graph. So
Stephen, can I just interrupt?
Yes, sorry, Russell, yep.
You've just grabbed the y equals g of x. There may be some viewers who are not used to grabbing objects on the graph screen and moving them. Would you like to just mention how you actually grabbed it?
Yeah, sure. Just moving
on a handheld?
Yeah, sure, Russell. Thanks for that. If we just move the hand over onto the, using the click pad, the little mouse area, and once we get on there, if you hold the mouse button down, you can actually grab the function.
You'll have
I
to
can't
shift
do
the
that
text.
at the moment because it's actually a fixed thing, but I'll do it with the label. So I've just moved onto the label, grabbed it using the middle mouse button, and you can notice that I'm actually able to drag it around. This can be really useful if there's a lot of information starting to appear on the screen as well. If I let that go, I've now got it in the new position. Obviously I couldn't move the graph around because it's actually fixed based on that function. So yeah, thank you, Russell, good point there. Just quickly moving on, because I do have another question I want to get through. I'll just go back now. The next question was looking at the idea of g of x in turning point form. Now, a little trick here for students. If I go into menu, and one of the questions was, what is the turning point of this particular graph? They can obviously see that from the picture itself. But if I go into algebra, number 5 is complete the square. Now, within this rule, what we need to do is say that g of x is the rule that we want to complete the square on, because that was the graph we want the turning point for. The variable is x, and if I press enter, you'll now see that the rule y equals is negative x plus 1 to the power of 2 all squared, take 3. So our turning point was negative 1, and -3 using the terminology that the students would have learnt. If we come back
If
to the
teachers
graph,
want to actually have it as y equals there, if you go back to that one, you can actually enter that line as y equals and then complete the square following the y equals, and it will display the way you wish. So if you just put y equals on the new line and press enter, it will put it into the form that a lot of teachers will probably prefer.
Yep, and I think that's a fairly new thing, isn't it, Russell? I don't know if I've seen that one, but yeah, that actually does make it a lot more user-friendly for the students, so that they now think of it as being y equals rather than just a rule, which again can cause them some problems with marks later on. Okay, just to finish off that question, just to go back to 3.2, and just to explain that we can show the turning point, so menu, analyse graph, and because it's a maximum, if I now pick the graph, I've got to choose which graph because there's two graphs on there. So if I move the hand over the graph and click on it, pick the lower bound, pick the higher bound, and we've got our turning point. So again, either way for the students, the question did ask them for it to be in the turning point form first, so 3.1 will actually help them with that. Just another little quick trick, and then we'll move on to question 3. Some courses, particularly into the higher senior courses, want to look at inverse functions. Now, just to quickly show you how you can do that, if we open up a text box again, now for teachers teaching 2CD and 3AB and a little bit in 3CD, for the idea of inverse functions, I won't go into the mathematics here, but for the teachers who have seen this before, we're basically rearranging the function to make it x equals. So if I do that, you'll know, actually I'll do that for g of x because it's actually a slightly nicer graph. So what this is doing is now giving us the inverse function graph. And if I move that up to the axes again, for teachers who have actually taught it or who need that, you'll actually notice now that we also have the inverse function graph. So there's a whole lot of little cool tricks that we can use with the idea of that text box and using the defined functions. Okay, finally, and I won't go through this whole question because it is fairly lengthy, but to just give you an idea of some of the little tricks that we can do and for our students to have them prepared. The last question is a standard normal distribution, binomial distribution type problem. Again, mainly done in 3CD, but the little ideas I'm about to show you here could be very valuable across all courses. So the question says, it is found that 70% of students make the same mistake in a calculus examination question. A random sample of 40 students who are sitting the examination was taken. Let X denote the number of students who make the mistake. Is X discrete or continuous? Discrete because we're talking about a count or a whole number situation. What type of probability distribution is X? State the mean and standard deviation of the distribution. Okay, this is where I want to now use the calculator. What type of probability distribution is X? It's binomial because there's either they get it wrong or they get it right. In this case, highlight to the students that success can be mistakes. So in this case, 70% being a mistake, we're actually still saying that's the student meeting the needs within our survey. All right, so I'm going to come back to my calculator, create a new problem. This time I'm going to create a notes page. So if I add a notes page, and what I want to do is just get the starting part of this question done. So we want to actually look at the students having a template that they can actually use within an exam. Now, I'll do this just with one heading, so I'll put binomial at the top because this would be something the students would want for binomial. We might put something like sample size. Okay, now, the key pieces of information that students want to glean out of this question for the mean and standard deviation is they need the sample size, they need the probability of success, or in this case, making a mistake. So we're going to press Control-M to create a math box. Now, the maths box is where we can now start putting in some of our mathematics to that students can move and manipulate and then use for rules later on. And within the exam, they can actually change various numbers within this maths box, and that will have an effect on all the other rules. So in this case, the question was that their sample size was 40. I'm going to store that, so Control and var, and you'll notice that I've got the store arrow come up, and I'm going to call that N for the sample size. I'll press Enter. Now I can move back up to the previous line and just press enter and then maybe put success. Go back into my maths box by pushing down, and then 0.7, 70%, is going to be stored as our probability of success. The next thing that they wanted was the mean within this question. So if I go mean, now because I want to now use the previous values that I've stored, it's a better idea to actually define it as a rule rather than using the store. So I'm actually going to call this M for mean. If I use the word mean, it causes some problems because it's a mathematical function already built into the calculator. So I'm going to use M, and I'm actually going to define it because I want to actually do some calculations and later use those calculations for other parts of the problem. Now I can either type in N or go up to my var key and pull down N times var and P, so the two things that we've used earlier. If I now press return, we've now got our mean, which was the sample size times by the success, and we get 28 as our answer. The other thing this question wanted was the standard deviation. Okay, and if I do, I think my maths box has moved down one line. If I just bring that back up again by deleting the blank line we just had. Okay, so now we want standard deviation, so let's call that maybe SD for standard deviation. I want to store that. Now the standard deviation is the square root of N times the probability of success P times, and we want the probability of failure for this particular rule, so 1 take P. And if I press enter, there's our standard deviation. So pretty much we've now answered the first question, which is, or sorry, the second part, part B, state the mean and standard deviation of this distribution. Now the beauty of this maths box idea is we can now go up and change things. So if I suddenly say that there's actually 30 students in the sample, if the success was, say, 80%, what you'll notice is happening down the bottom is the values are actually changing for the student. So they could have this as a template set up that they can call upon within the exam and use those values as they go through. Okay, I might look at one more part. I know Jodie's got plenty of great things to show you as well. So I might just show you on the next page, just to finish off, and then I think people will get the idea of how to apply this to the rest of the question by looking at what I've done. I'm going to now pull up another problem, another page, Control I, add notes. Now the next question was finding the probability of exactly 35 students making a mistake. So I'll put just probability, I might put prob just to save some time. We're going to put a Control M for maths box. Now what we want to do here is it was 35 that we want to store it as being the probability that we're after. So X was going to be 35 within the original question. If I press return, now we want to find the probability of getting 35 students out of the possible 40, which I better go back and just quickly check, and no, I've actually left them as 30, so I better change it back to my original problem. Go back to 42. So now what I want to do is actually have it so the students can change anything within this maths, this notes page, whether it's 4.1 or 4.2, and get the probability to appear straight away. Now the beauty of notes, I can go into menu, I can use calculations, so we've got all kinds of different options here. I'm going to go into number 5 for probability, number 5 for distribution. Now this is actually going to be a binomial PDF because the question is actually after exact values, so binomial PDF. All right, now I want to call upon the values I've already typed in. I could type them in here, or I could actually just click on the right arrow and it'll actually bring down a pull-down menu. If I pick N, tab down and do the same thing with probability of success, P, and because I've now called the X value X, I can go there. If I go OK now, we'll find that at the moment it's coming up with a probability of 0 because of the fact that I probably haven't changed something in my earlier part, just rushing through this and trying to get it finished. So, but what you'll find is that you'll actually get a probability PDF and it'll actually give us our values. I might just see if I change the value here. It may even be something to do with my rounding here. Let's
just go back to 4.1 and see what n was. Your x is bigger than n.
No, we've got 40 is...
You've got 40 there, yep.
Yep. I'll just come back here. I'll just quickly try again. I don't want to cut into Jodie's time too much. Just try 25. There we go. There's obviously something with me fiddling around with that notes page earlier that just messed things up a bit, and that's something you need to make sure your students are aware of. But what you'll notice there is I've actually just changed that value here, and it's quickly showing live what the new probability is going to be. On that note, I was going to go through the rest of the problem. I think teachers can sort of see the general idea of what you could set up for your students. It is a very useful way of getting students through these problems, and rather than having to access the menu all the time, they've got that document there available for them straight away. But on that note,
quickly describe how to save that, because if they're going to take that into an exam, they'll need to save it.
Yep, on the document I'm going to send out to you, it does actually talk about saving documents, but we've got a couple of choices. We can go Control-S or Control and then our little calculator icon up the top. I tend to talk Control-S with my students because they're used to Word and whatever else. So Control-S, and you'll find that they've got an option here of My Documents, and then they can actually either create a new folder or they can call it a new name, and again, it's just a matter of tabbing through the options or using the arrows. They can call it a new name, and then they can just save it. Then when it gets to the exam, the students can go into, and I might just go back to my home page, they can go into My Documents, and it would be saved here under whatever they've actually called it. So, yeah, hopefully that helps, Russell.
Thank you.
All right. On that note, I will pass over to Jodie. So thank you very much, and hopefully that's given people a few ideas of how we can deal with things. Okay, so over to you, Jodie.
Wonderful. I've stopped playing Candy Crush and we're ready to go. Share my desktop. Here we go. Hi everyone, and thanks for showing up today and webinar. The first things I'm actually going to look at is just a couple of points from the examiners, one of the examiners' reports that came out last year after the exams. And it made some quite interesting comments about the use of the calculator and just for the students. And for the students out there, make sure you read your questions very carefully and make sure you answer what's being asked. Very simple, but often a really common mistake. It talks about making sure that your answers make sense. The calculator will more often not give you an answer, but you need to make sure whether the numerical solution makes sense, whether it's within the expected range, or whether it's just completely crazy. Also, in the Calc Assume section, use the calculator to make sure you can check your numerical solutions. The calculators can be used to compensate for poor arithmetical and algebraic skills. It's there for a purpose. A couple other relevant points. Sometimes the solution will require an x value, and other times it will require a coordinate, so make sure you answer correctly. Take care when drawing graphs and diagrams. You've got the technology there to assist you doing that, so when you actually put it on paper, do it carefully. And do it so it is very readable. Remember, the exams get scanned these days, and poor images make it very hard for them to mark. Other points, always round to the required number of decimal places at the end of the calculations, where you can do it in your calculator, cut and paste the numbers through so you're using the maximum number of decimal places. Don't just truncate it or round it early. Don't do it in the middle of the calculations. And lastly, remember that the recursive formula and rule always has a first term, and I reckon that's the easiest mark on the entire paper for them. So make sure you actually put down the first term. Okay. Now I'm going to have a look at a few sets of questions. The first one I'm going to look at is a stats question. It's a group data. We've got midpoints, frequencies, and the kids need to be aware of the capability of the calculator. We can't put in a range, so we need to put a midpoint in. So I'm going to call mine midpoint. And I always encourage the students to name the data columns. It makes it very easy. And then You can't use the word frequency. I like using the word freak. And then from then, the students can go on and place their data in, piece by piece, building it up, midpoints, frequencies, and as all the best television chefs do, here's one I prepared earlier. I used mid-P for the midpoint and free for my frequency. From there, we can actually do the calculations. And the students, once they got the information correctly, are pretty good at going manual statistics, stat calculations. This is one variable. And even though it's group data, we only have one list of numbers. Our X list, we used free. No, we used mid-P. And our frequency, we used free. So as you can see, other data variables that I've used before are still there, so you need to be aware of that. And I want the results to go into column, in this case, column C. And I will go, OK. And up pops the information required. So in this one, we wanted to estimate the nearest mean sale price. So we can go through here. Gives the title, gives us the mean, 325 straight up. It also gives us a whole variety of other scores, max, median. It doesn't give you the range, but it's not too hard to work out the max. Take them in, or the interquartile range, which is the Q3, take Q1.
Jody, which standard deviation are you using in Western Australia? S of X or sigma X?
It depends on the question. This one was a total population. If it was a sample, we would use the S of X, and then the total population, we use the olive, as I like to tell the kids. Steve, you got any input on that?
Most usually it's the sigma X. Just from, the 3AB, 3CD course content would normally use sigma X in most cases. I think Sadler over here actually touches upon the S of X idea in his textbook and says that for what we use in exams, focus on the population.
Yep, unless it specifically says it's a sample.
Yeah. Unless it's very clear, stick to sigma X.
So that's how we go, and that will give us the estimate of the mean price and the estimate of the standard deviation. From there, students will often be asked to interpret the information. Sometimes they round, in this case, the nearest 10 cents, so they actually need to make some decisions about what the meaningfulness of the data. It's a straightforward process, but they need to manage the variables, manage the numbers, and get the information in correctly. Now, the next question I'm going to look at is a capture-recapture. And if you note here, I've got a URL, https://Google. This is where you can actually download the file. We'll also make it available via the website. I think we can actually have the files there. But this is, you want to write that down now or screen capture it. This is where I've got it for the kids to use. And my students will have this on their handhelds, so the capture-recapture process becomes easier. So, in this situation, I'll go back and make these numbers ridiculous, and then we can go through and take it up. Talking about entering information, don't forget the multiple trials make more accurate estimates, so reinforcing those points with the kids. We'll move along to the next tab.
Jody, can you point out on the second line where you've got no recap and you've got it in blue but not green showing? Just tell them how important it is to press enter there.
I will. Okay, each of these blue things are part of maths boxes. And we show the input, which is the blue 100 that I entered. So in this case, in the tag situation, there's 12 lizards that we caught initially. I have to hit enter. comes up green, and that shows me the data's there. Then we go to the total number of recaptured. That 4's there, but it hasn't been entered, so it hasn't been dealt with. So we need to make sure we're in there. And the total recaptured was 8. Then I hit enter. Then the green 8 will come up, telling me that I've entered the data, so it's part of the calculation. And the number of recaptured, the tag recaptured, becomes 3, giving us a total population of 32. So it actually goes through and steps it out. So this is another maths box 2, using the variables tagged, number recaptured, and the recaptured tagged. So it shows the kids clearly what to write down, remembering that they can't get more than a couple of marks without actually writing down some working out. So they need to make sure they're doing it and reinstating and reaffirming the fact that they might need to do it multiple times. So they can go through, and if they've got variable sets of data, the next one was 15, and there was 6 captured, and of those were 2. So we've gone from one number, the next number is 45, so we can record those numbers on the next sheet and we can average them out. We can determine the mean of each of the times that we go through and do that. So that's a file that I would download, share with my students. I'd either send it out to them via Navigator, put them in the docking bay, put it on my handheld and share one-to-one. So there's 3 different ways of getting files out to the students. The students may be able to do it at home with their student software and put it on themselves and then share it with each other. But it's a good use of the notes page to do something simple, but make sure they get it correct each time. Capture-recapture is an easy concept, but the kids will mess things up occasionally, so this removes that opportunity for them to type in the wrong things in the calculations. So as long as they get the amounts in, they should be fine in working it out. Okay, the next thing I wanted to talk about, I'll make this a large screen. I don't want to save the changes there. I'll create a new document. I will look at the calculated document, and I want to look at a bit more of the functions and some of the capabilities as we move into 3AB. So if I define a function, g of x, then go control and the colon equals, or the little duck symbol as some people like to call it, whoops, outside the bracket, and I'm going to go 3x to the power 3, drop that down, take 4x, enter. So I've defined this function g of x. If I want to look at it again, hit G, it comes up bold, so g of x is there. I can also find the values of g. So, and that gives the point x4, y176. So the kids can get the values from there, which is really important. We can also go through and do some of the calculus work with those functions once we have them. So, I'm going to go menu, calculus. I want the derivative. I'd like the derivative of g of x. So with respect to x of, type in g, or I can just hit the variable button and that'll bring me up g of x. And there suddenly we have the first derivative. First derivative is really useful. And as we say to a lot of the 3AB kids, especially the weaker end, if in doubt, derive and put equal to 0. So let's do that. Let's go solve. We can either put the whole part here, or we can just go up arrow there, Control C, and Control V, or we can just hit enter. Control C, Control V is better. I have no idea where that number's come from. Control C, Control V. Anyone want to tell me we're getting $5 only? I'm just going to go up here and hit enter.
Yeah, press enter.
680, I'm really happy that that's appeared from nowhere.
Yeah.
That's a bug, but at least it's now been recorded. So we're going to solve that equal to 0, and that gives us two values. X equals minus 2 on 3, x equals 2 on 3. And that's really good. For us, we can pick it cubic, normal cubic. We can spot the ones which are local max, local min, or stationary point. The students will take it a little bit easier way. We'll insert a new page. We'll go Control I. We'll go at a graphs page, and we can graph just the original function. And that'll show us the stationary point here is a local max, the stationary point there is a local min. And we know what those values are because we've actually come up with them algebraically as well. So from there, we can make other calculations depending on what the question's asking us. It'll also allow us to do double derivatives if we really wish. Menu, calculus, derivative, X, with respect to x. I'll go back up here to here. That, which you can navigate, and I'll hit enter again. Whoa. I'll be in the box, and then I will hit enter. And that'll give us the second derivative as well. I could have done the second derivative with respect to x twice of gx. I think that just makes it too messy for the kids to read. So it gives 18x. So we can actually go through and get the second derivative.
Now, Jody, would they ever be required to do the second derivative in the one move?
Not normally.
Right.
You'd normally step through it.
Okay.
It's, they're not used to writing straight CAS questions.
Okay.
They assume that you need to go through the steps to get there.
Okay.
Because if we can do that, but I'll leave it that way. Rather than do the double derivative. Okay. So, if we want to graph any of these things we've been doing, so I want to graph a derivative, so I want to graph d of x, and I would like that to be equal to the derivative I had. And go back up again, and d of x will be the derivative. Go back here. Press tab, and I can graph d of x. As we thought, it's a parabola. It crosses at minus 2/3, 2/3. So the kids can make some more statements from there. Some of the students prefer to analyse the graph. They can find the maximums, or the local maximums, by moving across the lower bound there, and then just moving across there. But as you can see, that'll give the approximate value rather than the exact. And the exact value they got back on the first page. So if they wanted to find out the actual turning points, the actual stationary points, we go back to our original function, g of x, and we go template of minus 2 on x, and that will give us 16 on 9. We can go g at 2, go divided by 3 instead. It'll change it back to the same formula, minus 16 on 9. So as you can see, mine's set up for exact value. If you wanted one of those answers the other way, we can bring it down, and we can go control and the approximate, and that'll actually give you the approximate answer. I like working exact and then moving to approximate occasionally in some courses, and other courses I will set them up in approximate. And I know the guidelines that Steve's got will actually go through and discuss which is better for which course. 2 CDs, mainly avoid the exact values, but when you hit 3 CDs, exact values, radians are really important. Okay, I think that just about sums it up. One other thing I wanted to go through is you can actually use calculator various piecewise functions. Here's one I produced a couple of grand finals ago, I think, and sent through to my Victorian friends. But just want to let you know these things are possible, and if you'd like the instructions, I'm quite happy to share them with you. I have my class build it up piece by piece and into grown at the end once they put it all together.
You better use this one, Jody, for the next 2 weeks. You won't be able to use it after that.
Oh, okay.
Sorry.
That's good. If we're done there, do you want me to pass you back to you, Russell?
No, Jody, would you just go back to your previous document that you had with that graph on it, where you did the maximum, the actual physical maximum? A very, very important thing in the Australian curriculum and in the Victorian course as well, and perhaps it is the same in the Western Australian. If you just do a maximum again on that blue graph, yeah, so just delete that. Just right mouse click on that point and just delete the point that you've already got. Okay, and just go part way through doing the maximum. Just click on the graph, but keep to the left a fair bit. Now, when you start just moving that a little bit, you'll see the word maximum there. Just take it back to the left. Just take it back to the left. Yeah, the word maximum there on the TI. It is very, very important that this word maximum doesn't by default mean a stationary point or a local maximum. It's telling us here that that's the maximum within the domain we've got selected, and that's a very, very important difference in the courses of a maximum, whether it's a domain maximum or whether it's a function maximum or a local maximum. So, of course, once you go past that turning point, that maximum value doesn't change there, so we know it is a stationary maximum. So that's a very, very important concept that you can actually show using the drag feature here. Yep. Okay, thanks for that, Jody. If you want to pass back to Stephen for a moment, I would like to ask Stephen a question here.
Yes, I will have it and give it to Stephen. There you go.
Yes, Russell.
Stephen, one of those questions you had was asking about domains. It was a question part a little bit further on than what you covered.
Yeah,
Are you able to go back to that document?
Yeah, I'll just get back and hopefully still have it up. Yep. So which one were you after, Russell?
Okay, all right. Well, just one of the questions there, if you go to the actual question itself.
Oh, yep, the question. That.
We've just got a couple of minutes. We can have a look at this one here, because the TI can do these ones here. So if we look at part F, state the domain of the function g of x. Now, in the calculator page, of course, we can actually use the word domain. So if you've still got that function defined, g of x, which I think you have, yes, you have. All right, so if you just go to a calculator page, just brand new or wherever, it doesn't make any difference. You can either type in the word domain or you can get it from the catalogue, which is the book.
I'll type it in just quickly here.
Yeah, domain.
Yep.
Open your brackets, g of x, comma x, and press enter. And that actually gives you the domain of your function. So, no, it won't give you the range there. But your function max and function minimum will give you your range if you want to do it that way.
And I was actually going to mention that, Russell, that for something I was going to go through earlier is that a lot of teachers try to teach range and domain without looking at the graphs. Very much recommend that you take it always back to the graph so that
well and truly.
Yep, I agree with that.
Yep.
Sorry about that. Go.
Okay. Well, thanks for that. If you'd like to pass that back to me, Stephen?
Yep. Went too far. Sorry. We'll do it again. Okay, should be back to you, Russell.
Okay. Hopefully you've got my desktop coming through now?
Yep.
Okay. Well, thank you to Stephen and Jody. An excellent summary of, of 3 actual courses, which made it a little bit more difficult because we've got to try and make it appropriate to as many of the participants as possible. The feedback, after you close out of this webinar, there will be a survey for you to fill in. It's very, very important if you can complete that feedback, because it allows the organisers here, including the presenters, the hosts like myself, and also TI, to actually make changes as necessary, or you may have wanted to see more calculator activities, whatever. That sort of information is very, very useful to us. You'll also get an email within a couple of days after this webinar obviously is finished, which is now, and that will give you additional links to the material that the presenters used, and also some other key materials. The TI website now contains a lot of Australian-produced material, so the Australian website, including YouTube, so you can see the YouTube there. So it's basically just going to the YouTube site and putting in TI Australia. The other very, very important website is just to go and put in TI space Australia, and it will bring up the Australian website, and you can just navigate through the tabs, the resources, teachers, upgrading your calculators, a lot of the how-tos, a lot of activities are very, very useful for all states and the Australian curriculum. And of course, 1300 138 140 for a local call to the Australian Office of Texas Instruments to answer any of your questions with products, or if you've got some queries, some questions that you're a little bit worried about, including technical questions like how do I do a certain task, then if you call them, they will pass it on to people like myself or Stephen or Jody or Peter Fox there, and any of the other trainers, and we're quite willing to help you through. Okay, we'll call it quits at this stage. I think our time is up. Thanks very much for joining us in for this Western Australian webinar on the examinations. Thank you.